So hello everyone, I'm David Festal from Red Hat, software engineer at Red Hat, and working on the Eclipse Che product mainly, and recently mostly on integrating with Kubernetes Operators. And the talk will be lightweight, standalone, and composable Che workspaces with Kubernetes Operator. But first, maybe just a quick explanation about what Che is about. I think probably most of you already know. It was announced by Eclipse as the first open source Kubernetes native IDE, and also other aspects for developer teams in the homepage. Maybe I will, if you want more information, you would be able to assist other talks. Let me just focus on the Che 7, so the current Che architecture. On one side, we have the Che workspace, which is really what the user wants, the developer wants to be inside, with a full-blown IDE based on THEA, language server, app runtimes. And on the other side, you have a Che server, which is a monolithic component that will create those workspaces, manage them, manage authentication, backed by identity management and a database. So let's discover it more with a demo. It would be, I think, a bit clearer. And then I would do live demo on the Kubernetes CRD aspect. Okay, so it's already started. Sorry. Yeah. So let's go to the Che dashboard URL. This is the entry point of the Che product. And then we come to a full-blown UI where you can manage your workspace, administration, organizations. Then choose a project, here Java with Spring Boot and MySQL, and create the workspace. Then, of course, you have to load a bit for all the bits of the workspace, which are all based on containers to be loaded. And in the meantime, let's look at the definition of a workspace, which is a Devfile here. We can see that we have commands, projects, and components that are fully defined in only one file. If we come back to the workspace, here we see that it's starting. So the main Che server takes care of starting the workspaces for all the users, because the Che server is multi-tenant and will manage all the workspaces for all the users throughout the enterprise. And we can see first one thing here at the bottom. It's listing all the plugins and editors to install. So it's managing all that. And then downloading VS Code extensions, because we support VS Code extensions as well. And finally, all the plugins have been processed. And then it's going to start all the containers, because Che is really, and a Che workspace is really something that is fully container-based and containerized and kube native. Maybe I'll go a bit faster here to gain some time. We can see that it created the container MySQL, container verifier, and then we will finally, if the video wants to continue, we will finally open the workspace with all the elements inside that the user can use. Okay, so now laptop. Probably cloud is more robust than laptops, it seems. Or probably live demos are better than video players. Sorry about that. Well, yeah, that's it. Now we arrived into the Che workspace, sorry for that. And we can see that on the left, we will have the list of all the plugins that are installed into the workspace automatically. We can see here the Java language server, for example. On the other side, we will see all the tools that the user brought into his workspace. We can open a terminal, do a maven command. We can run a command in another container to prepare the MySQL database, for example, and then we can go through the list of all the plugins that were pushed into the workspace to provide all the required tools. And so let's start that and just have a look to the resources on the Che server that are required for that. We can see that we have Kcloak, Identity Manager, Che, the Che server, and a database. And all in all, it's mainly 1 GB only to manage workspaces. So that's the main point of this part. And now, if only we had lightweight, standalone workspaces as first-class Kubernetes citizens, we wouldn't need the left part, which is mainly Che server, Kcloak, data store, classical monolithic applications. And we would like to keep the Che workspaces, which are really kube-native, containerized applications on the right, with everything that is interesting for the developer. So why not take the Che workspaces and sort of push them into Kubernetes, inside Kubernetes? In other words, extend Kubernetes with workspaces. Currently, workspace drive, the workspace definition, drives the creation of standard Kubernetes objects. Okay, and the Che server manages that. And we could go one step further and really make workspaces themselves become pure Kubernetes objects. And now it's possible since Kubernetes has become extensible a few years ago through custom resource and finally operators. So custom resource definition, just a word on operators. Custom resource definitions allow adding new types of Kubernetes objects, Kubernetes resources into the cluster, in which you can define your own metadata, specification, and expected status. And then you have the controllers, which are generally quite small Go code applications that will run inside Kubernetes and reconcile the expected and observed state of the custom resource. You express what you want, and then the controller makes so that it's done. And then operators lately arrived to bundle those two things into a single unit that can be easily installed. So what does it mean in terms of Che? Currently, what we have, workspace data is a Che server specific model. And the same also, workspace structures only is really meaningful, you know, it's a Devfile, as I showed. But then runtime desired state, runtime effective state, all this is stored inside the Che server application with, you know, internal Che server specific model and inside a Postgres database. And also for the logic, from inside a single dedicated server, you have to manage all the Kubernetes objects. And then, of course, you have to do in-house management to define the rules and to check that everything is in sync, because you have Kubernetes objects, you have states stored into your database, and you have to maintain sync between all these with a custom logic. This is what we have currently. And what we could have is have everything be custom resources. The Devfile is already Kubernetes syntax, Kubernetes-like syntax. And then we could have a Kubernetes resource with the Devfile, the expected state, and the observed state of all this bundle into a custom resource. And of course, then we can store this directly into the Kubernetes cluster etcd instance, which allow us dropping the Postgres database. And on the logic side, everything would be done inside a custom, a Kubernetes compliant CRD controller I spoke of before. And this is something very well-defined, with very well-defined and simple logic. And also it's typical crude resource reconciliation. You have a resource created, you have to create the underlying object, you have something deleted, you have to delete them. So it's very simple and systematic logic. And then, of course, we don't have to sync any runtime status because everything is stored in the custom resource. Well, in fact, it already exists. In early development, we have already a Che workspace operator in the Che incubator project, GitHub repository. And of course, it needs cleaning, documentation, testing, but the concept is really there and validated. And the idea is to have the same experience as what we saw together, we saw earlier, but with simply doing kubectl apply. So we will do that now. Here I have several terminals. Let me show the logs of our small, yes, that's it. Yeah, okay. So these are the logs of the controller that is running and that will manage all the workspaces inside Kubernetes. Then let's show that we precisely use exactly the Devfile that we showed previously, but only we have a workspace here with a name, a status, started or stopped, and then just the exact same definition of the Devfile. Sorry. So let's start. Let's install, create this workspace inside Kubernetes. We simply kubectl apply samples Java MySQL YAML, and we can see that already the controller detected the workspace here, but it's still stopped because we had this state in the customer source. So now let's start. And that's very simple, just a patch command, kubectl patch spec started true. And then we can see that many things happened on the controller side, that we created a number of objects here, ingresses, deployments, everything that is needed to have all the workspace running inside containers. So in the meantime, we will wait for it to start. Oh, yes, I have problems too. Yeah. Yeah, and the time I try to copy-paste, the workspace is already ready. Let's try to get the workspaces that we have in this namespace, and then we can see that we have our workspaces and that it's status running, and now we have also the URL to be able to access it directly inside the browser. Let's put that here. And we find exactly the same thing in which we arrived from the dashboard initially, which is exactly the same workspace. Sorry. Let's see here that we have the plugins list. On the right, we have the same, exactly the same tools. We can also run Maven, provision the database. Everything works exactly the same as what we had before. So now, let's stop this workspace. Again, just a simple patch command. And we can see again that the controller is reconciling everything, removing all the objects that were created. And then, if we switch to our workspace here, it has been deconnected. And if we try to refresh, of course, then you can see that we have nothing anymore. So, what happened here? We have lightweight, standalone, but then we have also composable workspaces. That means that workspace become components, building blocks. You can get every application in Kubernetes will be able to see workspaces and to do things with it. Also, you can inherit all the Kubernetes goodies that you have for any Kubernetes resource, for example, monitoring, event aggregating, open API schema, sorry. And let me show you an example of integration. If we come back here into the namespace where I created my workspace, I can see that here I'm in the OpenShift administration console that you probably know, maybe. And it's just one of the flavors of Kubernetes. And if I go into the operator, this console is a sort of web application inside OpenShift that allow managing all the Kubernetes resources. And what we can see is that we already gain everything for free. We can here go into the Che workspace and find our workspace here and see that it stopped. If we start it, then we will follow all the conditions. We will see all the containers that are starting. We will arrive at the same state of workspace that is started and that we can use directly using this URL. This is typically, and this is for free. We didn't program anything in the console here, just because workspaces are custom resources. So this is how these new workspaces are really embeddable into any Kubernetes-like or Kubernetes native application. So we don't have any component anymore. We don't have any database. It's dedicated to Kubernetes. We don't have any Che server anymore because mainly all the information is in the custom resource already. And we don't have any identity management. So we lost authentication, it seemed. But in fact, authentication as well can be delegated to Kubernetes. But it's a bit trickier because you have many different and incompatible implementations of what an identity provider can be. So there is a solution which is mainly composition. You can switch controllers to manage a given custom resource. For example, for those who know, ingresses can be managed with different controllers according to the type of network you want. And we can do the same here. We decompose custom resource with a workspace, container, basic services, and a workspace exposure, which is how the workspace will be exposed on the network. And then you can provide several controllers, a main controller for the main workspace, and a secondary controller that we can configure for the exposure. So let me show that to you. Here we have the workspace. Let's stop it. And if I go into the YAML here, I would be able to add something in the specification. We can add the exposure class here, which is mainly with what type of network we want to have next network exposure. And let me just switch it to OpenShift OAuth, which is an example of alternate exposure of a workspace to the network. And now let's restart it. And as soon as it's started, it should normally bring us directly to OpenShift authentication to be able to authenticate all our workspaces. And it would be the same. I showed that for authentication, but it would be the same for authorization through Airbag, for example. Also for network access, typically Istio. We could even think of this type of design principle, of composition, to choose the way we want to deploy the workspace. I'm thinking of scale to zero workspaces with Knative instead of deployment, for example. So that's really a powerful thing. So it's now running, and if I click on it, you can see that I changed the exposure of the workspace, and that now, clearly, I have to log into OpenShift. Let me log as a developer here, before arriving into the exact same workspace. Yeah, so I just explained this one. And so finally, what's the idea of all this? What does it bring? And it's not only because we like kubectl, it's not only because we want to have a quick setup for personal use, it's not only for the fun, if it was quite fun, but not only to be trendy or Kubernetes-like, it's really, there are important stakes behind this new way of creating Che workspaces and really benefits for the overall Che solution. Briefly, a big enabler for the future of Che overall, because you don't have external central components required. So that makes it easy to integrate, easy to manage, releases the burden of maintenance, and also, of course, saves resources, as we showed previously. And then using Kubernetes design patterns from the ground, it would enable really massive scalability. You just add clusters, you just federate clusters if you need, and everything is stored in etcd database and managed in deployments that will be created on each clusters. And of course, it will open the Kubernetes ecosystem to Che, leveraging all the features that are provided by operators, currently growing ecosystem of operators. And last but not least, it would also allow us unlocking the Devfile extensibility. Applying this composition mechanism that I showed with the OpenShift authentication would allow us typically providing the Devfile, but allowing adding new type of components, custom components that any user would like to inject into his workspace. All this is not only for lightweight workspaces, but would be very valuable for also developer teams. And so why would we continue this way? Mainly in order to enable the wider spread of Che workspaces throughout all sorts of Kubernetes infrastructure, not only basic, but also with any authentication mechanism, for example, in all sorts of software context, because you can now embed a Che workspace inside another application as a custom resource. But on the other hand, while reducing the management and the maintenance burden, which is quite important, and also improving scalability and performance. And my opinion is that this work would be really worth it to make Che even more Kube native. So I don't know if you have any question about that. Sorry, excuse me, I didn't. Yeah, the good news here is that everything is bundled into an operator, and an operator is both the data, so the definition of the custom resources, and the operator that work on this data. So you just can, you have, on OpenShift, for example, you have operator hub on Kubernetes as well, because there is a Kubernetes version of this, and it's just mainly very specified so that you can add descriptors, and then all the rest is provided for free by the underlying infrastructure. So yeah, it's really very easy to install and quite lightweight. I didn't show that, but it's mainly 10 times smaller than the main Che server. We were at 1 gigabyte, and roughly due to the underlying system of the Docker image, the controller is 100 megabytes, possibly. Yeah. Yes, so this is stored publicly. This is open source in the Che incubator repository, GitHub repository. Of course, if you want finished docs, complete tests, you will not find them, but it will come. Yeah. Any other question? Yeah.
Do you have any integration with Ansible?
Not really, yes, because Ansible is also used in the context of operators, but as far as I know, more to provide operators to be compatible with the operator framework from legacy Ansible applications. So in our case, that's not really a need, because we started from scratch in coding the operator in Go. So we didn't really need Ansible for that.
My question is Ansible is also trying to help with the deployment. And this Eclipse Che is also trying to say, okay, get your journey easier with Kubernetes. Are you directly compatible with?
Yeah, I mean, no, it was not really in the scope of this proof of concept. And so I didn't explore the way, Ansible and operators might collaborate in such a context. To be honest, I don't have the answer to the question. But yeah, typically this was really focused on using the Kubernetes operator controllers and CRDs framework inside Che. And then, of course, possibly Ansible might be useful in other areas, I assume. Did I answer the question correctly? Yeah, sorry. Any other question? Currently, it's a proof of concept, but quite advanced in our thinking, I would say. And so also present in the roadmap that we already showed yesterday, if you remember. So yeah, that's an ongoing proof of concept. Yeah. Any other question? Oh, great, I thought I was late, and finally we have time. Yeah, and if anyone wants to discuss that afterwards, it's... Yeah, okay, yeah, that's it.